Do you guys remember? I think we studied histogram in Seaborn. I think it was sns.histplot. The thing is, in matplotlib, you have a separate function for 2D histogram. In Seaborn, it was not like that. Let me just show you. For example, let's import all the libraries. Yeah, so let us create some random values, okay, as we usually do. I'll just give a title. So whatever we are going to learn now, it is called as 2D histogram. So let's create data again using NumPy. So I'll just create x is equal to np dot random dot rand. Let me check if this works. Okay, and print x, you will get this. Are you guys able to understand what we did? So we are using this np.random, and within this random, I think it is better if I give you as homework. There are a lot of different functions to generate random numbers, and every function generates the numbers in a unique way. For example, there might be a function which restricts the range of the generated numbers, maybe to something like -1 to +1, or there might be a function where you can limit the range by yourself, or there might also be a function which generates random integers. Are you guys able to understand? So what this does is this rand n, it will give you a set of values, in this case 100 values, and these values that are generated, they are following the normal distribution. Let us just cross verify using Seaborn sns.kde plot and x. So you get this. Are you guys getting the same plot? Hello? No. Acha. Yeah, maybe we can do that. np.random. Yeah, can you guys check by using random seed 42? Okay, good job. Yeah. And now you can see this kind of looks like a bell-shaped curve. Am I correct? So you have all the major points distributed here in the center because you have a broader region and then there is a peak. And as you go away from zero, either to left or to right, you can see that the density decreases. So when there is less probability density, it just means that there is very less probability that a random point or a point in that distribution might occur at that point. So this is how we used to plot um, KDE plot. If we want to plot histogram, hist plot. Okay, so this is how it looks. Let's create Y also. Then we'll compare this with matplotlib 1. So again, if I use, okay, this is something that we can test. Let's just remove this. If we write again np dot random dot random 100, no error. Okay, because we are using random seed only once, I wanted to test if x and y will be equal, but it says the values are not equal. Are you guys able to understand what I did? Okay, okay. Let's just try creating one more random seed and test it. This time let's go for 52 or 43. That's what it said. Let's just remove random seeds and then check. Okay, okay, it's different. Then it's good. Np dot random dot seed. Now let's plot histogram using Seaborn. SNS dot histplot, and within histplot we had to write x comma y. Okay, so this is how overlaying is happening. But I think we can give x and y in the same function, as far as I remember what we did during the class. Anyone able to recall how we did? Hugh, I don't think so. Wait, we'll try. Let's just create one more code and write sns dot histplot. We'll now specify the parameter x is equal to x, y is equal to y. Oh, it worked. Are you guys able to understand what happened? Okay, so the thing is, I think if we don't specify anything, it just takes one positional argument and whatever variable that we are giving as input, it will give the histogram for that variable. But if we try giving two variables like x comma y without specifying it, it becomes difficult because I don't think it will be able to directly read it. When we specify the parameters, as you can see, if I click on this hist plot, am I yeah, I'll get this documentation. You can see here, if we had a data frame, then we had to specify the data parameter as well, but there is no data frame. So we have specified x and we have specified y. Hope you guys understood. And again, yeah, bins is set to auto. So this is how we used to do it in histplot. But now what we are going to learn today is we have to do the same in matplotlib. So if we write plt dot hist 2d and x comma y, let's check if this works. So we get this. Are you guys getting the same plot? Okay. So what we can do, we can write plt.show to remove all those things. Yeah, now the graph looks clean. Let's try adding after x comma y. Are you guys aware of how to interpret these? I think I taught you in Seaborn. Based on the intensity of the color, you have to interpret. For example, if you just focus on the center dark blue box, most of the values have the probability, or most of the values contain x value within the range of this minus 0.5 to 0, and y value of the range 0 to somewhere around 0.8. So this is how you interpret it. Like maximum values are having the probability of being present in this numerical space. As the color intensity becomes lighter, there is less probability. And here, when it's a histogram for a single variable, you interpret it based on the height as well as the width of the histogram. Hope you guys understood. And this one, again, this is for homework. In Matplotlib, you have different color palettes. And this one, I think it's Viridis, if I'm not wrong. You can search for what are the color palettes available. If I write Viridis, okay. So for the color map, I think this color bar is also a default parameter. So we can write color bar. We got the error again. It's Viridis, sorry. Yeah. So if you want to change the color, because of this color bar parameter, you have the color bar here, which will help you understand. For example, 7 is being represented by this yellow color, dark blue is representing 0. This hist plot by default, I think it takes count, if I'm not wrong. For example, if you go to hist plot, there is something called as stat, and if you set stat is equal to probability, I don't know, sum, it will be by default count. Okay, let's try changing this to probability. Okay, so what are the available values? There is frequency, there is density, there is probability. So if we take probability, this is what we get. Are you guys able to understand what I'm doing? Like, I'm not explaining because I thought you are able to understand. We learned this in Seaborn. By changing the statistical parameter, we can visualize different types of histogram for the same data. This is the histogram where the statistical parameter is set to probability. Again, if you make an error here, you can get to know what are the things available. So there is frequency and proportion and percent. So in the same way, probably, okay. So in the same way, here it was where it is, and you have the color bar here. Let's just check what are the things available here within the PLT Hist 2D. Okay, I think stat parameter is not there, or maybe it is present. We are not able to see at the moment. That's okay. So within the color bar, if you just write this, you have got just the color bar. If you want to have the label for the color bar, what you do is within the parenthesis, you write label is equal to the title of the color bar. Maybe count in the square. Are you guys able to understand? Here, yellow color box is indicating that there are almost 7 values that have the probability, or where the x value for those 7 values is between -1 to -0.5, and y value is 0 to somewhere around 0.5. Are you guys able to understand? Okay, cool. Now let's create some complex function, a random function. Okay, let's just change the y. So what we will do is we'll write x into 2.0 plus. So we have got a different y formula. Now let's visualize the histogram. So it looks different now. Again, how you are going to interpret it is going to stay the same. There is not going to be any difference there. And I think we haven't used few parameters that are important in matplotlib plotting. That is plt x label to label the x-axis, plt dot y label, and again we have to also add plt dot title as well, which is going to be the main title for the plot. In Seaborn, you will specify all these things within the single parenthesis. In Matplotlib, you will have to write multiple lines. And you can change the color map. For example, if I make the error here, you can see that it has given you the list of color map options available. Are you guys getting the same? Okay, so let's just use blues, BLUES, and let's check how that looks. Okay, so the error is because I haven't specified any x-axis label. And you can see wherever there is dark blue, that square is representing the region for high probability or high data density. Are you guys able to understand? In this case, it says wherever there is dark blue, count is going to be near to 10. So these squares have almost 10 values present in that range. And hope you guys understood the 2D histogram. It is very simple. And again, there is something called as alpha. If you want to play with alpha is equal to 0. Let me take it 3. You can see I have got the lighter version of the same 2D histogram. Can you see it? Even the color map, the color bar that you had earlier, even the color intensity of that has been decreased drastically because of the alpha parameter. If the alpha is set to 1, you can see this. There is dark blue, which is clearly visible, and then there is white near to 0. But if you set it near to 0, you will get that lighter version of the 2D histogram. And then there is one more parameter. Bins will be something that you can play with. Um, you can decide if I write 10. So there are going to be 10 bins. So 10 bins is nothing but 10 squares on one axis. So if I pass a list, let's check if that works. Yeah. So here I have given a list as input. You can see that if I zoom in, there are 10 rectangles. They are not squares now because number of bins in x and y axis is not equal. There are 10 bins on the x axis. There are 20 bins on the y axis. Are you guys able to understand? Okay. In this way, you can see if I compare this with the original plot, if I don't write anything, it will be 10 for both. In that case, you don't need a square bracket. Yeah, it looks like this. So you are increasing the number of squares. And sometimes if you increase the number of bins too much, it becomes hard for you to interpret as well. So this is something you can play with again. And in this distributions, there is a concept. There is one concept which says that all the values present in the distribution, they have the same weightage. For example, do you guys remember? I think we learned something called as asymmetric error and symmetric error. Yeah. So in some distributions, every value contributes equally. There is no particular weightage. For example, if I just create a data, if I create a data, or if I write something like maybe there is like 10, 12, 13, 14. If there are four values in one distribution, all the values contribute equally. I'll write 1 comma 1 comma 1. All the values are contributing equally. If I have the same four numbers where 12 contributes more than the other three, so in that case how I can write is I can tell this as weights of numbers. When weights are equal, every number contributes equally. When weights are not equal, for example, in this case I'll just say that the number 10 contributes just 10%, that is 0.1, and where 12 contributes 80%, while the other maybe 13 contributes 50% and 14 contributes 20%. Are you guys able to understand what I'm trying to say? Okay. Okay, okay. So this is something that you can do within histogram. I'll just leave that for you again. There is a parameter called as weights that you can specify. You can specify the weights for variables. And I think this is all for 2D histogram. Now we can go for hex bins. Again, hex bins is something that we have already studied in Seaborn, so it's not going to be difficult. In hex bins, instead of square representation, you will get the histogram in hexagonal representation. Do you guys remember that? I think in Seaborn also we did that. Okay, so okay, let's try one more thing. What if we can uh, like create overlay of histogram and scatter plot? So I can just write x comma y. This is alpha. That's okay now. I'll just write one more where I'll write plt dot scatter and then x comma y comma c is equal to, let me want that in red, and also let me specify the transparency. Yeah, are you guys able to understand? Here even you can better see wherever there is dark blue region, more points are there, and wherever there are light blue regions in those squares, there are few points. Are you guys able to understand? I just created an overlay of scatter plot and histogram. Now coming to the hex bins, there are few other parameters as well. You guys can look into it. Now coming to hex bins, again this is very simple. We can just write plt dot hex bin. Here you will have something called as grid size, and if I increase the grid size, this is what's happening. Are you guys able to understand? The hexagons became much smaller and it kind of looks like zoomed in message, sorry, zoomed out image. And if it was 10, this is how it looks. And also, when you increase the number of grid size, you can see there are more dark blue hexagons than they were initially. And even I think the color bar is changing. If you can notice, here it says dark blue indicates 2. That is count within the square. It should be count within the hexagon or hex bin. So it is 2. If I change the grid size to 10, you can see here dark blue indicates 12 points. Are you guys able to understand what's happening when we increase the grid size? Okay. Again here, if you have color bar, that is better so that you can interpret better. If there is no color bar, it becomes very vague. For example, if I don't use color bar and if I just print this, I know that in the dark blue region there are more points, but I don't know how many points are present. So in that case, this color bar, it acts as a, we have this in chemistry lab where there is uh, a manual with colors, and it is like used for measuring pH. If we dip a paper into a solution based on the color, I think there is something like that. So that is what I'm trying to say. Hope my example was understandable. Now, there is something called as, again, here you have bins in the hex bin, and bins is set to, let's say, 30. Something happened, even I don't know what exactly happened. Okay, this one I don't know, guys, what exactly is happening. I'm being honest. Because here number of hexagons is not changing, or even if it's changing, I don't think it's much varying. And then there is one more parameter. Again, if I'm not wrong, it is called as minimum CNT. Yeah, it is like minimum count. For example, if you want to visualize those hexagons where minimum count is 2, you don't want to visualize those where minimum count is less than 2. Like you are ignoring it, it doesn't matter. So in that case, you can use this function to specify what is the minimum count in the hexagons or in the bins that you want the values to be present. Are you guys able to understand? Let's check, because even I myself haven't used this. Okay, so here, whatever we are getting, we got only 4 hexagons, 5, 6. You can see it's light in color, and these, whatever that are present on the plot, they have minimum 5 values there. If I increase it, or sorry, if I decrease it to 2, you can see I got more hexagonal shapes on the plot. Are you able to understand? Okay, so this was one parameter. And yeah, I think this is pretty much even regarding hex bins. And I thought of covering ECDF plot. Do you guys remember ECDF plot from Seaborn? Empirical Cumulative Distribution Function. I have some confusion regarding that plot, so I thought I'll cover it in later classes. Because I was looking into that plot and it said there is no function for ECDF in Matplotlib, but the Matplotlib documentation says there is a function. So I had some confusion there. I'll just show you. If you go to the documentation, we have covered all the pairwise plots. We have also covered all the distribution plots except ECDF plot. Here it says ECDF is there, but there was some confusion. So I thought I'll cover this in later classes. And now we are skipping this gridded data for now. Maybe we will learn this in night slips. We will try to complete the 3D and volumetric data plot before the semester starts. I think we are going to have the sessions till 5th of July, as I said. So we'll try to cover as much as possible the 3D plotting. Would that be okay? Okay.